A buoyancy!
All right, let's do some buoyancy. Buoyancy, you guys, is the force of a displaced fluid that pushes up on an object. So really, like in non-science terms, what we're talking about is when you put something in water, you displace it or move it out of the way, there's a force that also pushes back up on it. That's the force. Buoyancy is the force that you feel push up on your arms when you try to push a beach ball down underneath water. We did it in class.
Water pushing back.
Yeah, it's water pushing back. Basically, it goes
Opposite of
against gravity. Gravity
Yep.
pulls down. Buoyancy is going to push up. It only happens in a fluid. There's no buoyancy on land.
So the idea of buoyancy stems from something that's called Archimedes' principle. And
Eureka!
yes, that was wasn't that the myth that he said eureka when he figured it
Yeah,
out?
supposedly it was
naked
naked.
Greek guy jumps into a bathtub, sees a bunch of water flow out of the
Eureka!
bathtub.
And then runs around naked.
Yeah,
Which really all Greeks did. So I mean,
Yeah, it really wasn't a
Yeah.
weird
So
thing.
can we say he didn't?
And
Yeah.
that's how science works. But anyway,
Yep.
so Archimedes realized that when you put an object in water, the force of the water pushing back is equal to the weight of that fluid itself. So like in other terms, let's say I myself jump into a bathtub. I weigh 180 pounds of pure muscle. That means
Pure
there's
muscle.
a force equal to 180 pounds that pushes back up. So the higher amount of water that gets displaced in terms of weight, the higher the buoyant force it pushes up.
Yep.
True. So what actually causes a ship to float, you might ask? Because, we look at these things and ships are made out of like chunks of steel basically. And
Yeah, and steel doesn't
fiberglass and-
float on water.
Not
Steel is
normally.
way more dense than water, which means it's going to fall down to the bottom
It's
of the water.
greater than 1 gram per milliliter, so it should sink. But
Yeah. But because of buoyancy, it floats.
Yep.
Listen to this.
the weight of that fluid that ship pushes down is greater than the ship's own weight, which is really kind of crazy to think about. You have like a 2-ton ship, pushes out more than 2 tons of water. The buoyant force is then strong enough to keep up and float it, and therefore its density is less than water if you include the buoyant force.
So what you're saying is if an object can displace or push away at least as much weight as its own weight, then it'll float. So if the ship
Exactly.
weighs like 50 tons, it has to push away at least 50 tons of water
Yep.
to float. If it pushed away like 20 tons of water, then would it sink?
Yep, which is how submarines work. Subs float, but then what they do is they fill their ballast tanks up with more water to add more weight, and then they can't displace enough anymore, and then they go down.
Can't fish do that too? Isn't there a way that fish do that?
Yep, they have this thing called a swim bladder that they use.
And they let air in and out, and it changes their buoyant force, and then they can go up and down because of that?
Exactly.
I saw that in Discovery.
Good old Discovery Channel. So, like, let's say I have this block, not really block, but this piece of aluminum foil that I folded over a few times. Now, it's not very buoyant, but think about how I would take this piece of aluminum and I would actually increase the buoyancy. In other words, lowering the density. So remember, what's the formula for density?
Mass divided by volume.
Right.
Yes.
So, is it going to make, what should I add to this, mass or volume? Is it going to make it more buoyant if I add mass?
If you add mass,
I think
it's
make
going to
it
be
less
more
buoyant.
dense
Right.
and less buoyant. So adding mass would make it sink more easily. So probably you want to add volume, make it bigger.
Right.
Right.
Right, and the way you do that is you spread it out, yeah.
Oh.
So it is the same
takes up more
mass.
So look how much
Right.
space it takes up now. It's a lot more than it did before. And
Now-
but you didn't change the mass, did you?
Right. I could probably make it like boat shaped too. That's gonna float perfectly.
Yeah.
Look at that. Look at my wonderful little.
That's awesome.
I might go canoeing
It's
later.
the new Titanic.
All right.
Hey, and it's floating.
And you don't see, I just threw it in the tank of water. And, it
And I
floats.
totally didn't just hit the microphone, guys.
So-
Not at all.
As we just said, you increase the volume of the boat, not the mass. So the volume meaning how much space it takes up. So when you do this, I'm going to try not to drip water on my computer, but you kind of, if you can see my boat, this whole area where there's just air, that's kind of included now in the
Yeah.
volume.
It's
You
kind
sort
of
of view it as
rounded.
this block. Even the air that is contained in the area of the boat, that still is calculated into the density.
Yeah.
And that's why I've taken an object that is more dense than water and made it less dense than water, because I've created all this empty space inside it, which way lowers the
Yep.
density.
Think of it, you got a big pocket of air now that's
Mm-hmm.
in there, which allows you to have a lot lower density.
That's why basketballs float, and
Exactly.
beach balls float, and footballs float.
Because like we've talked about even with your little example, those soccer balls, they're deflated, they would sink in the water.
Yeah,
Yep.
yeah. Once you take that volume of air out, they
Yeah.
should.
Yeah. So anyway, one little thought question, and this will be the last thing we'll do, is you have two liquids, one with a density of 1 gram per milliliter and one with a density of 2 grams per milliliter. If you put a rubber ducky on there, let's pretend the rubber ducky has a density of like 0.85 grams per.
So it's
wait,
gonna,
it's a solid, so it's grams per centimeter
grams
cubed,
per
right?
centimeter cubed because it's a solid.
Right. So which liquid is it going to float higher on?
We're going to leave you guys with that. We'll talk about it in class. Might even be asked right away when you come in after these notes.
Yes. So we'll see you later.
Laters.
Bye.